Hello there guys, my name is Mike and today we are going to talk about the variance. So what the variance does is giving us a number that summarizes the deviation of some observations from their mean. Now how the formula is constructed, it's designed to give more weight to bigger deviations than small deviations, and that is coming from the power, from the square, from the power of 2. One part of my video will be about this. The other, we're going to refer to the probability attached to each observation, and the third, we're just gonna do as reference the actual deviation from the mean. So first thing first, let's write down our observations. Let's say I have 1, 2, 3, 4, 5, 6, 7, and 8. Now, the mean of these observations, the average, is 4.5. Now, if I draw a line, let's say that's the mean, which is 4.5, and I want to depict the deviations of each observation. Let's say this is 1, this is 2, this is 3, this is 4, 8, and so on. Now, the variance formula equals 1 over n times the sum 1 n x minus nu square this is x is equal, okay. What this formula does is that this is the probability of each observation, because each observation has equal chances of coming up. So each one of these has a probability 1 over 8. Then we see the actual deviation from the mean, which is this distance here for each number, okay. And then we have the square component. Mathematically, okay, let's take, for example, 8 minus 4.5 is equal to 3.5. Seven minus 4.5 is equal to 2.5. Now, 6 minus 4.5 is equal to 1.5. We can see that the difference between them is 1 of the actual deviation. But what happens when we square it? 8 minus 4.5 squared is equal 3.5 squared is 12. And 6.25. This is 2.25. Okay. We can see now that the difference is 6 and 4. So the power square makes bigger deviations having more impact than smaller deviations. We can see here that the actual deviation difference is just 1, but with the square power it's 6 and 4. So the higher the deviation, the more the impact it will have on our variance. So this formula is designed to give more impact, more weight to higher deviations through the square formula. Many people mistake the square that its role is for make the deviation positive. But this is not true, because if that was our purpose, we will just do this like 1 minus 4.5. Voila, it's 3.5. But no, the reason that the variance has the square is to give more weight to higher deviations. Give more weight to deviation 3.5 than to deviation 2.5. Also, another thing to notice is that maybe a number, not all numbers have equal probability attached to them. Like maybe one number has probability 2/8. That will be because our distribution is not 1, 2, 3, 4, 5, 6, 7, 8, but 1, 2, 3, 4, 5, 5, 7, 8. So in that case, I will do 2.8 times 5 minus 4.5 squared. That's it.